So I thought I would show a few REPL sort of things to show one how to use the REPL in certain ways. Not really the entire workflow necessarily, but sort of useful functions to use and so on. And also some of the additions that I've made to our development containers uh, that in part make it better to use the REPL and yeah, to improve the experience, let's say. So let's start a project first. So stack new uh, REPL project, Quantarol basic. And again, what's happening here is that we have the name of the project and we have the template name. So the Quantarol basic one sets up a very, very basic structure. What it does though is that it enables language extensions by default, which makes it so that we effectively have a basic sort of standard language that we are working with and learning and so on. And it also sets up development containers. Let's open REPL project. Let's first create a Git repository. And what I'm going to do here is reopening container as usual. And so let's first look at the obvious. We have library.hs here. This is the default one that you get out of the box. And let's open the REPL and see sort of what this is about, right? If we execute stack REPL here, we're going to jump into, well, the REPL. In our development containers, what I've done is I've set the prompt here to Q angle here, which it sort of should signal to you you're in a development container of our sort of doing, right? And yeah, the REPL is effectively, it has by default loaded your modules, first of all. So for example, if we have these functions here, first I'm going to show one thing that could be useful to know. If I execute main here, you might think, okay, that's going to execute this code. However, there are two mains, and it's going to tell you you have two mains. It could refer either to library.main and main.main. If I type lib and I press tab here, this is the only function that actually exists with this path, sort of, and that executes our code. If I were to change this code here and make it a lot more screamy, you would not see this reload by default. However, there is a command :R or :reload, and now we have reloaded our code. So if I make this change here, so I can do this with :R, or if we want to execute the last command we executed, we can actually do only this, :. This will execute whatever we executed last. And that's a useful way to sort of have this muscle memory, switch to the terminal, : enter, and so on. So if we want to know what we can do in the terminal, we can input : question mark. This will give us a list of things. And so all of these are things you can execute as essentially : commands in the terminal. And of course, this is a lot. I don't think you actually need to learn all of these. To be honest, it's just a lot. You don't need all of these all of the time. So I would suggest a few to get sort of familiar with. One of them being type here, this type here. Could also be useful maybe as a kind of learning exercise to use kind, but you might not actually need this. There's a section in the Haskell materials that uses this to show some information about types, and that might be useful, but it is unlikely that you will use this. I think over time as you're using Haskell. There is, however, a command that I will find here called browse. And this is useful because it allows us to browse a module. So for example, if I wanted to know what was in the library module, I get this. What is in main? This, right? So this is a very short and sort of concise way to get information about a module, right? And let's see what we have here. Here you see repeat last command is just colon. Browse we have there. Right, we can try out doc. Let's see if we can find docs for this here. Right, so you get a short text based on hadocs. This is the sort of documentation language that Haskell uses. So if you want to know something about some value or whatever, you can execute :doc. Of course, you can go to it in your files and so on, but this can be fairly useful. Also, I should note info. So for example, if we're wondering about some kind of construct, let's try something random. Here I've asked for info about I/O. You get some information about that type in this case, right? We can see which instances it has in terms of type classes. So we can see that I/O is apparently a monoid, right? It's a monad, and so on and so forth, right? So this can be useful. For example, if we wanted to know more about monad fail, we could actually ask about monad fail. So this gives us the definition of monad fail. This won't necessarily give you the docs about monad fail. We can ask more questions like this by asking doc monad fail. And info is useful, especially for you have loaded a code base that already has a lot of things inside of it. You want to know more about, like, hey, is this custom type that someone has? Does it have an instance of, what does it have instances for, right? And this is extremely useful. So let's see how this sort of interacts with code a little bit. And I will also show off some of the additions that I've made so that your output is actually better. So what we're going to do here is I'm going to add a function here. Let's say it's a list of ints. Well, it's a value technically, but let's say new function. I'm going to, actually, let's let that be a compiler error when it happens. So let's take 10 from that and filter for even. Actually, we're just going to do this for now. This has nothing to do with what I'm trying to do. Let's do that. You'll see here we don't have access to AND. So let's try to see, where is AND actually? If I run Hoogle here, you've probably seen me in some presentation perhaps, use Hoogle. Hoogle is a search engine for, well, type signatures, packages, and so on. So let's try to use this here. So first of all, we can say this, right? And we can see that this is in data function. However, sometimes we might wonder, like, how do I get something that is of this type, for example, right? And this is of course what Hoogle is really good at. So if I were to do this, we will also get the same results, right? These are functions that have that type, right? So as long as we can be fairly confident about that the type is correct, we can actually get to a result fairly easily. So let's say, for example, that I have a function that takes a to b, and I have a function that takes b to c. This should give me a function that takes a to c. I may have to put quotes around this. We will see. I definitely needed quotes around that. So all right. So these are the results, right? And we can see here, these are the actual function names, right? These are the modules they're in. So really, if you have something that matches a certain type, this will allow you to simply search for that type, right? And that can be extremely useful. So let's see if we can Hoogle for this one. I keep forgetting these quotes. That should be a lesson for everyone, I suppose. So let's take a look at what happens if we execute this function, because now we know that in data function this exists. We're gonna have to put some parens around that. Now this seems to be working, right? The question is though, why do we not have access to this here, right? This means we need to reload. So we're gonna reload, and now we should have access to a new function. And I want people to sort of note what's going on here, right? First of all, we have colorized output by default. And second, we have prettified or pretty printed output. This might seem like a silly thing to have now for this case, but in the sort of grand scheme of things, when you're working with the REPL and you're trying to fetch data, for example, right? You have big maps or you have big objects that you're decoding into, and so on. This is really indispensable. It's well worth it to have this kind of maybe awkward output for this simple case, right? And sure enough, if we were to, let's say we had 50 of these. Oh, right, import data dot function. Of course, this is the pathological case where, yeah, this kind of looks awful. If we had 100 of these, we would just fill our terminal. But this is not really the most common sort of case, right? If we're working with these sort of big structures and so on, it's, like I said, indispensable to have this pretty printing going on, because otherwise it becomes very awkward very fast to try to scan an entire object sort of and have to respect the boundary over here and so on. This gets really tedious, right? So I think this is a very useful thing to have like this, right? And so that's part of what I've added lately to these development containers. This is enabled by default. We might look at sort of being able to disable them. So far, I don't really see a point, but we will see, I guess. So in the terminal, we can obviously execute code. So far, though, I've executed only pure things, right? So I would like to sort of show that we can actually execute a bunch of stuff. Is that how you should develop always? Well, not necessarily, but it can be useful to sort of get get a handle on those things, right? So if we were to browse system.directory, I think it is. Oh, right, okay, so package. I suppose I should explain this. Can I actually do this? Unknown command, let's say, there is a command for this, I have forgotten it. Usually I add the package to my stack REPL and so on, but let's see if we can sort of get this going right. It can be useful. Actually, it could be set dash package directory. Perhaps browse system.directory and voila. Okay, so this is obviously a, well, big module, as you can see. Here we have a bunch of functions, most of them pertaining to effectful things. So for example, we can copy files, we can copy permissions, blah, 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 create directory. So let's take a look at sort of creating a directory. I'm going to import qualified system directory as directory. And you'll note here that I'm just writing Haskell code, right? It's essentially just the same as writing it in a module. Now I have directory dot create directory, right? This takes a file path, and if we look at what a file path is, we can actually see, right, this might be in directory, not file path. Oh, hang on. Let's see if we can find this prelude.filepath. Of course, I have qualified import of prelude. We are going to look at this. It is just a string. It's an alias for a string. If you pass a string to it, you're going to be just fine. So what we're going to do is we're going to execute. Let's take a look at our files here. So we're going to execute create directory with the name test directory. See what happens. And it was executed. So we have no problems doing effectful things, right, in the REPL. So with that in mind, let's try to get values out of the REPL, right? Because we can execute effectful things, but can we actually also get values out of those effectful things? And of course we can, otherwise I wouldn't be saying this. So for example, let's use list directory. Some people will know this as ls, for example. List directory. First of all, I'm going to execute this, sort of just have it print things, and then we're going to take a look at sort of binding the result and using that result. And we're also going to sort of look at the types of these, right? So first, what is the type of list directory? Well, it takes a file path. It returns IO of list of file path, right? We know the file path is just strings, so it's going to be a list of strings, right? So let's see if we can execute directory list directory and just pass it a dot, right? And sure enough, we get our list of files, right? So what if we wanted to bind this? Well, it's fairly simple. By the way, I pressed Control A to get to the start of the line. This is essentially an Emacsism. If you press Control E, you're going to go to the end. So here, I'm going to say file paths. I'm going to bind this, just like we would in code. You don't need to be in a so-called do notation in order to do this in the terminal. So what is the type of file paths now? Well, it's a list of file path, right? We have effectively unpacked the IO, basically, and we have these file paths now. And so that's what we have in our value. If we print them, we get this. We can now use them just like anything else. Let's say we take 3. Prelude take 3, and we get 3 of them, right? And this is very useful. You can, for example, execute your functions. You can essentially write code here in the terminal and then transfer it, sort of the thing you know, into your files. So this can be very useful. I should note there's like there's a thing that happens usually when you want to put a type on something, and it can get very awkward in the terminal. So I'm going to show how to do that, right? So for example, if we were to, let's say we're going to create a new function called get current files or get local files, right? Normally, if we did it like this, I'm going to put a prime on this just for this example. This would be directory dot list directory with the current path, right? We're now just defining a function that does this thing, right? And that's all fine, right? But let's say we wanted to sort of be more assertive for one reason or another with the type of get local files, because if we look at it now, get local files, I mean, it has the correct type and so on. But let's say we wanted to ensure that in the terminal, right? What we're going to do is we're going to execute get local files, or rather type this, right? And we're going to say this is prelude.io of prelude file path. And this is the same type we saw before. So in this example, it doesn't really make a difference, right? But you're gonna stumble upon cases where it does make a difference, and you want to sort of, or you want to use this as a safeguard. Am I writing the correct expression? What we're gonna do here now, because if we executed this now, we get this, like, there's no variable with that name, right? Okay, that's awkward. So what do? Well, what we do is we put a semicolon here, and then we say get local files is equal to directory, list directory with this. And because of this semicolon, we have effectively sent two different commands to the REPL. And so now we have this definition, and we know it makes sense because we wrote this type here, right? If I were to make a mistake here, let's say it's, I suppose, ints. Well, prelude ints. Very sorry. Now we get a type error. So we can be fairly assertive and say, yeah, this has to match this. And it can match these because we have written the type and then a semicolon and then the definition, right? So this is useful when you know you want to put a type on something in the REPL, but you can't do this multi-line thing, right? And now I'm actually going to try something because I've literally never tried. Let's say prelude file path. I'm gonna try inputting a new line here. Yeah, no. So you have to write this on the same line. And I think that's fine. The REPL is not necessarily for writing entire swaths of code. It can be a very useful thing to sort of write get local files here and say, okay, so this is a function that returns IO of file path. Get local files, import system directory qualified. And of course, here's going to complain, well, you haven't told me that directory exists. So what I'm going to do here is actually going to quit the terminal. This is not necessarily something you have to do. And then I'm going to go to package.yaml. And I realize I probably haven't showed this before. So here we have our dependencies. And you can see we don't really depend on anything currently, right? If we do this here, we just add directory here, because you'll note it's a member of the hidden package directory, right? So when Haskell is telling you something is a hidden package, it means one of your dependencies has this, basically. But you haven't set your thing up to use it, right? So what we can do is simply add it to our package.yaml, and it will now be essentially visible to the rest of the project. If I do a stack build here, stack build fast, we're gonna see a compilation error apparently. Right, I have written the wrong type for file path, or get local files rather. Now, what we see here is that, yeah, this is not working. If I were to do stack REPL here, we now have get local files available, right? And it does the same thing as before. It's literally the same definition. So with this in mind, let's look at one more scenario where if I were, for example, to say, I'm going to add a new module. So new module. This is our file name. It's going to be in the same directory as library here. New module where? Hello from new module is a string. So this is what we have currently. You'll note, by the way, that string here is undefined. This is because one of the extensions that we use by default is that we don't have a default prelude. Meaning, if you want standard behavior or the standard prelude, you're going to have to import it. Right? And so what happens now when we reload? Well, it seems like only 2 modules were loaded. So if I write hello and tab, nothing happens. Right? And there are a few solutions to this, but I will say, honestly, the simplest one is simply quit stack REPL. It's there now. This is a fairly simple solution. This is the case because this automatically created REPL project.cabal file here. Well, it's going to be your project name.cabal, right? This actually is rewritten when you add something in your project. So for example, let's say simple new file other module.hs. So actually, let's take a look if it's already added it. Indeed it has, right? So immediately when you add a new file, what's going to happen is that that file is going to be added to your cabal file, right? However, the cabal file is not reloaded in your REPL, right? So it doesn't know about this. However, what we can do, module other module, where hello from other module is a string. So what you can do here is you can say load, and we should be able to say source other module.hs, right? This will load the module in our project, right? You'll note, however, if I say hello, now we only have access to hello from other module, right? So we lost access to new module. So what you can do here is you can load several modules. Or you should be able to. Let's see. Right. So we can load files dynamically in the REPL. This is not really an issue. However, there's kind of a problem there, right? Because you lost everything else. So let's take a look at adding modules but not having this behavior. And you'll note, of course, when I did a stack REPL here, it finds other modules. So now if we type hello, we have both of these. So hello from new module and hello from other module. Both are visible, right? And so what happens when I want to sort of add a new module, but I don't want to discard all my progress. And to be fair, I haven't done this in a while. So let's say additional module.hs. Prelude is sometimes hard to type. as we expect, of course, we don't have access to this module here. We still only have these. So let's take a look at the help commands. And like I said, I haven't done this in a while, but let's try to make it happen, right? There's a module command that we will find. So module plus here. If I remember correctly, we should be able to say module plus additional module. Don't quote me on it, but module plus additional module. Right. Can we write source? We cannot. Okay, so this one is interesting. I do know that we can, for example, say module plus data dot function or others. So control dot category. This should be possible. And if we do show modules, interesting. Right, it's in the imports. It's effectively importing more things. When you do module plus, you're not loading only one module, you're adding to the ones you already have. Now we just have to find the ways effectively to effectively compile our new module and add it, but not lose the other one. So let's see if we can do that. And of course, there could be some argument to module that you can pass in order to do this. I simply haven't found this out. I wonder what this star does. I suppose let's not go too deep into that. Actually, what does add do? We may have found if we add source additional module, this is the one we're missing, and that works. So now if no, I still lose the previous ones. That's very interesting. Let's reload. Very interesting. In any case, this is how you use the REPL in Haskell. I would really recommend getting comfortable with the idea of sort of testing things out in the REPL and then essentially transferring that knowledge into modules that do the correct thing and so on. It can be a very useful thing when you're working with APIs. And of course, you can write your code in your modules and then simply reload, execute the functions on their own, right? This is part of the actual purpose, is to be able to say, well, I've written this get local files. What happens when I execute it, right? So yeah, I think that's it. And thank you for watching.